The power rule for the function f of x equals x to the power r, where r is any real number, then f prime x is r times x to the power r minus 1. The basic rule of the derivative of a linear function for y equals mx plus b, y prime equals m. Recall y prime or the derivative is the slope of the function. And for the line y equals mx plus b, the slope is m. Therefore, the slope is the same as y prime. Two special cases of the basic rule. If f of x equals c, then f prime of x equals 0. Recall f of x equals c is the constant function, which will give you the horizontal line. And the horizontal line, the slope is 0. Therefore, the slope or the f prime x equals 0 for the function f of x equals c, or the constant function. The second case, if f of x equals x, then f prime x equals 1, or the slope is 1. This is the line y equals x, and m is 1, or the coefficient of the x. Therefore, the slope f prime x equals 1. The general case of the power rule for the function f of x equals c times x to the power r, where c and r are any real numbers. So f prime x equals c times r times x to the power r minus 1. In this example, we'll find the derivative of each of the following functions. Part A, f of x equals 5. This is the constant function, or 5 is the real number. Therefore, the f prime x, or the derivative, is 0. Part B, f of x equals 5 times x to the power 3. This is the constant 5 multiplied by x to the power 3. The f prime is found by using the general power rule. 5 as the coefficient multiplied by the derivative of x to the third. The power r is 3, so 3 times x to the power r minus 1. Simplify to be 5 times 3 times x to the second, or 15x to the second, as a derivative of this function f of x equals 5x to the third. Next example, for f of x equals x to the power 1/2, the power r is 1 over 2, or 1/2. So f prime x equals 1/2 multiplied by x to the power 1/2 minus 1. Simplify to get 1/2 x to the power negative 1/2. And we call the negative power, we can write it as the reciprocal, or 1 over x to the 1/2. Or will be in the form of 1 over 2 times x to the power 1/2, which is the same as 2 times square root x. So there are many forms that they are equivalent to each other. Next example, find the derivative of gx given that gx equals 1 over x. So we are going to find the derivative, which is e prime x. For our case, the gx is 1 over x. We have the power rule. Therefore, we are going to rewrite the 1 over x as x to the power negative 1. So g prime, using the power rule, the power negative 1 now it becomes negative 1 times x to the power negative 1 minus 1, or negative 1 x to the negative second, which is the same as negative 1 times 1 over x to the second, or negative 1 over x squared. In this example, we are going to find the derivative of the hx with respect to x. This is another notation of the derivative h, or h prime at x. Okay, h of x is 18 divided by x to the power 2/3. Again, we are going to rewrite it as the power of the x, not in the rational form. This h of x is equivalent to 18 times x to the power -2/3. Therefore, the h prime x, after applying the power rule with the constant coefficient, so 18 multiplied by -2/3, x to the power -2/3 minus 1. Simplify the numbers. Then we have 18 and 3 that can be reduced to be 6. 6 times -2 or -12 multiplied by x to the power -5/3. And we can rewrite the power negative into the power positive as 1 over x to the power 5/3. Simplify to get h prime x equals -12 divided by x to the power 5/3. If f of x is a differentiable function, c is a real constant, and y equals c times f of x, then dy by dx equals c times f prime x. Or we can say the derivative of a constant times a function is a constant times the derivative of the function. If f of x and gx are differentiable functions and y equals f of x plus or minus dx, then the derivative dy by dx equals f prime x plus minus g prime x. In this example, we'll find the derivative of each of the following functions. For y equals 5 times x squared. This is the same as 5 multiplied by x to the second. So y prime equals 5 as a constant multiple multiplied by the derivative of x squared, which is 2x, or we have 10x as a result. The second example, y equals -4x, which is -4 multiplied by x. Y prime equals -4. As you can consider this as the slope of the equation of the line, or y equals mx plus b. In this case, the m, or the coefficient of the x, is -4, which is the same as the derivative of the y. In part C, if you look at the derivative of 5x squared and -4x that we found in part A and part B, these two terms combine into the new function y, or y equals 5x squared minus 4x. Y prime can be found by the sum of the derivatives of those two terms. In part A, the derivative of 5x to the second, which gives us 10x, and the derivative of the second term, or the second part in part B, is -4. Therefore, the derivative of 5x squared minus 4x is 10x minus 4 as a sum of two derivatives. In this example, given y equals x to the third plus 8 times square root x plus 2 over x, we have three terms, and each term we have x to the third. As the second term, 8 times square root x, we write it as a power. The second term will be 8 times x to the power 1/2. Similar to the last term, we write it as the power of the x, so 2 times x to the power negative first. And then we apply the power rule. Y prime equals 3 times x to the second plus 8 times 1/2 x to the 1/2 minus 1 plus 2 times -1 times x to the negative first minus 1 by using the power rule. And then simplify to get 3x squared plus 4 because 2 and 8 reduce times x to the negative 1/2 minus 2 times x to the negative second. And we can also write it in the positive power form, which is 3x squared plus 4 divided by x to the power 1/2 minus 2 over x to the second. For this example, we are going to find f prime of u if f of u is u to the power 1/2 multiplied by u to the second plus 2u. First of all, we are going to distribute u to the power 1/2 to both terms in the parentheses. F of u becomes u to the power 1/2 plus 2 by the property of the exponents. If you recall, x to the power m times x to the power n is x to the power m plus n. So 2 times u to the 1/2 plus 1 for the second term. Simplify the power, we get u to the power 5 over 2 for the first term, plus 2 times u to the power 3 over 2 for the second term. And then we are going to find f prime, or the derivative of f with respect to u. Using the power rule, first term becomes 5 over 2 times u to the 5 over 2 minus 1 plus the second term 2 as a constant multiple and then multiply by the derivative of u to the power 3/2 or 3 over 2 times u to the 3 over 2 minus 1. Next, we simplify the powers. We have 5 over 2 times u to the power 3 over 2. 2 and 2 reduced for the second term gives us 3 times u to the power 1/2 as a derivative of the function f with respect to u. In this example, if f of v equals v squared plus 1 divided by square root v, find f prime at v. First of all, we are going to simplify this algebraic term as v squared plus 1 have the same denominator. We are going to rewrite it as two separate terms at v squared divided by square root v plus 1 over square root v. And then rewrite it as one single power. The first term will be v to the second over v to the 1/2 plus 1 over v to the 1/2. Then keep doing similar way by using the property of the exponent by x to the power m divided by x to the power n equals x to the m minus n. The first term will be v to the 2 minus 1/2 plus the second term is v to the negative 1/2. Simplify a little bit, we get the first term as v to the power 3 over 2 plus v to the power negative 1 over 2. Next, we find the derivative of the f with respect to v. And we get 3 over 2 times v to the 3 over 2 minus 1 for the first term plus negative 1 over 2 times v to the negative 1 over 2 minus 1 for the second term, and then simplify to get the final result, which is 3 over 2 v to the power 1/2 minus 1 over 2 v to the power negative 3 over 2 as a derivative of the function f with respect to v.